Hello, good morning. My name is Mónica López-Velarde Santos. I am doctor in agricultural sciences by the University of Kassel in Germany. During my doctoral work, I worked with the Vinazas of the mezcal production. This is a residue material of the alcohol distillation, and I used it for the bioenergy production. I divided my doctoral work in 5 different stages, so I could publish 5 different articles. I have already published 3 of them. The 4th one is in the process, and I would like to tell you a little bit about my 5th article. So, the name of my article is the simultaneous electricity and biogas generation of Vinazas and cattle manure. Well, first of all, I would like to tell you why I chose this topic, the introduction about it, the methodology I used, the results I obtained, and the conclusions that I got. First of all, the mezcal and tequila, they are more or less the same. They are exactly the same, but the difference is that tequila has a denomination of origin, can be only produced in specific states in the Mexican Republic, and can only be produced from agave tequilana Weber. Mezcal can be produced in many other states and can be produced also from other agave sorts. Like in my case, I work with a mezcal from agave salmiana. The first step in order to produce mezcal or tequila is it begins in the agave fields, where the plants are selected to be harvested and haggled. After this, they will be cooked in a steam-heated masonry oven for around 72 hours. During cooking or hydrolysis, the complex sugars contained in agave will be transformed in fermentable sugars, like, for example, inulin will be transformed or hydrolyzed in fructose and glucose. After this process comes the milling step with a stone wheel, where the bagasse will be crushed and the juice will be also obtained. The bagasse are the fibers, and the juice is like a juice, like a liquid. This liquid will be fermented for around 12 days, and then will be distilled in a still in order to produce the alcohol. So I worked in a mezcal fabric in San Luis Potosí. Here are the rosettes, or the inside part of the agave. They were already haggled, and here will be cooked. That in this case, this is the steam-heated masonry oven, and then here comes the stein wheel to be in order to crush the rosette, and then will be fermented. And after fermentation comes the still, where the alcohol will be produced. Every time, or in every batch where a steam-heated masonry oven will be turned on, around 80 tons of rosettes are being cooked. From the juice fermented from this cooking, around 5 batch distillation process takes place. In each batch, or after each batch, 3 kinds of alcohols will be produced: 50 liters mezcal and 25 liters of other alcohols. That means, according to the boiling temperature, 3 kinds of alcohols are being produced. First come in the heads in form of methanol with a boiling temperature of 64.7 Celsius, and then come the ethanol, like the mezcal or tequila, both are ethanol, with a boiling temperature of 78.3, and at the end will be propanol, butanol, or isobutanol distilled. they have a boiling temperature of almost 100 Celsius. And from each batch, around 800 liter Vinazas will be produced. The Vinazas characteristics are, well, Vinazas are a residual material from the ethanol distillation, in this case from the tequila and mezcal distillation. From every liter tequila produced, around 10-12 liter Vinazas are being produced. In case of the mezcal production, because the mezcal production is not so industrialized like tequila production, around 8-15 liter Vinazas are being produced. Vinazas are rich in acetic acids, phenols and polyphenols. Has a lot of inorganic compounds like sulfates and phosphates. Have a low pH between 3 and 5. And they are discharged with a temperature around 70 and 90 Celsius. And they have a high organic matter content in form of chemical oxygen demand of 150 gram per liter and biological oxygen demand in 50 gram per liter. That's a lot of organic content. That's why Vinazas are a severe environmental problem. When discharged in water, they cause eutrophication, and when discharged in soil, they have a negative impact in the fertility and they cause toxicity. That's why I decided to work with the anaerobic digestion and the microbial fuel cells in order to give an utilization of the Vinazas, a positive utilization. I had already worked with the anaerobic digestion for a long time, and I found it like a suitable substrate in order to produce biogas. Basically, for the biogas production, we need a substrate and an inoculum, and the inoculum must be rich in methanogenic bacteria. Not only methanogenic bacteria is important, but also hydrolytic bacteria, acidogenic bacteria, and acetogenic bacteria. And normally the inoculums which are easy to obtain or are available is, for example, cattle manure or pig manure. And we need to mix this inoculum with a substrate so that the bacteria in the inoculum can be fed and can reproduce. And with the reproduction, then the bacteria will breathe, and this results of breathing causes the biogas production. And an important part of the biogas is the biomethane. Biogas can be used as a biofuel directly, or can be injected in a combined heat power system to produce electricity and heat at the same time. And in the case of the microbial fuel cells, well, a microbial fuel cell is like a battery, which an anodic chamber on a cathodic chamber. The anode will be connected to the cathode through a resistance so that a voltage can be produced, a direct voltage. The electrogenic bacteria is used to oxidize substrate like, for example, glucose or acetate, or inorganic substrates like sulfites or phosphates. And that's why I decided that Vinazas could be a good substrate for the direct voltage production. So I wanted to develop and test a biorefinery. What is a biorefinery? It's an integrative overall concept where different byproducts can be further used for the biofuels on biomaterials production. It's like a chain where the output material or the residual material of one process can be used further as an input material for another process, and then the residues of this other process can be further used for a third process, so that we have a further utilization of residues as far as possible. That's the biorefinery concept. So I decided to implement the anaerobic digestion as a first process and the microbial fuel cell as a second process. I designed first in CAD this biorefinery where the influent comes here inside. There is a bioreactor, and here is connected a hose where I collected the biogas in order to quantify or qualify the biogas. And then here comes the output material of the bioreactor, that's also called digestate, and the digestate would function like an input material for my microbial fuel cell. Here is the anode and here is the cathode, and both of them were connected with an external resistance so that I could measure how many voltage was produced. So I did first the design in CAD, and then I made a CFD simulation, that means a computational fluid dynamics simulation, in order to see if the velocity, what I could achieve with my peristaltic pump and the inlet diameter wouldn't cause any accumulation of fluid through the gas flow. So I needed to adjust a little bit the diameter and some other parameters, but I could obtain no accumulation here in the complete flow. Once I realized it with the CFD simulation, then I constructed this biorefinery in plastic. So I tested 4 different concentration of Vinazas with inoculum. The first one was a control with only inoculum, and then CA, CB, CC, and CD had every time higher organic matter content or higher SE ratio also. So a negative result, what I realized is that regarding the MFC, my highest voltage achieved of 0.43 was achieved with a control test. That means without Vinazas. No Vinazas, or the mixture of Vinazas and cattle manure was not suitable or very optimal for the microbial fuel cell. Regarding the concentrations with Vinazas, the highest voltage output that I got was with the CC, with a COD of 14.8 or an AC ratio of 0.5. An AC ratio of 0.5 is optimal for the biogas production. In relation to the biogas and methane production, well, we can see here the 4 concentrations normally according to the German norm, which I always use for my biogas production tests. I have to report the biogas production itself only from the substrate. That means I have to like the subtract the biogas production of the control test to each of the tests with substrates. That means only from the Vinazas the biogas production of concentration CA was around 130 liter per kilogram volatile solids, and then CB a little bit, also much more, and then we found CD the highest methane and biogas production. CC, the production of biogas by the concentration of CC was not very high. It was almost like CA. And well, in further analysis, I found out that the amount of volatile organic acids, mainly volatile fatty acids, was very high in this concentration, even higher than by CD. So that's why I got some conclusions, like Vinazas inhibit the voltage production because the control test showed highest voltage output. The lowest Vinazas content showed the lowest biogas, but also the lowest voltage output due to the lack of substrate. The voltage output increases Vinazas content up to a certain limit, where the saturated states of the electrolyte inhibited oxidation mechanisms. When using CC, the worst biogas production was given, but the highest voltage output due to the volatile organic acids accumulation of the anaerobic digestion. CC suggests that some Vinazas compounds, like for example, I assume inorganic compounds or the high amount of fatty acids, were not useful for anaerobic digestion, but could be effectively be used by the electrogenic bacteria in the microbial fuel cell. Well, that was a very brief resume of my work, of this part of my doctoral work. I hope you had learned a little bit about bioenergy, and in case you have any question, you can contact me. Thank you. Thanks a lot.